हेलो एवरीवन एंड वेलकम बैक टू दिस लाइव सेशन ऑन जीके। आज हमारा टॉपिक जीके का ज्योग्राफी है और लास्ट क्लास में भी हमने ज्योग्राफी कंटिन्यू जो स्टार्ट किया था उसी को आज कंटिन्यू करेंगे। उससे पहले आई हैव दिस इम्पोर्टेंट अनाउंसमेंट फॉर यू दैट द लास्ट बैच ऑफ फॉर कैट 24 is going to begin soon. So if you want to join, if you want to get trained by the excellent faculty at TathaGat, please don't make any more delay and join it soon. तो लास्ट टाइम हम लोगों ने एटमॉस्फेयर को देखा था और तो आज फिर से थोड़ा सा रिकवर करते हैं उसी टॉपिक को सो दैट वी कैन पिक अप एंड बिगिन। तो एटमॉस्फेयर का कॉम्पोजिशन सबसे नीचे इज द ट्रोपोस्फियर, जहां पे 75% ऑफ ऑल एयर इज प्रेजेंट एंड इसके अलावा इट इज द ट्रोपोस्फियर वेयर ऑल वेदर phenomena takes place। सारे वेदर फिनोमेना यानी कि क्लाउड फॉर्मेशन, प्रेसिपिटेशन, स्टॉर्म्स, ओशनिक सर्कुलेशंस, ऑल ऑफ देम ये ट्रोपोस्फियर में ही अकर कर रहे होते हैं। 0 to 16 लिखने का रीजन ये है कि अबव द इक्वेटर जो ट्रोपोस्फियर है, अगर एक ऐसा सेक्शन ले जिसमें कि ये इक्वेटर है और ये पोल है, तो इक्वेटर के ऊपर जो ट्रोपोस्फियर का एक्सटेंट है दैट इज 16 किलोमीटर, but it remains only around 7 to 8 kilometers over the pole। तो वेरिएबल हाइट है ट्रोपोस्फियर की above equator and above pole। This is important to know, that is why this poles versus equator। फिर आते हैं ट्रोपोपॉज पे। तो जहां पे जिस पॉइंट पे ट्रोपोस्फियर एंड हो रहा होता है या फिर ट्रोपोस्फियर की जो बाउंड्री है उसको हम कहते हैं ट्रोपोपॉज। ट्रोपोपॉज जहां पे ट्रोपोस्फियर स्टॉप्स, दैट इज ट्रोपोपॉज। जो इंपॉर्टेंट पॉइंट है समझने के लिए वो ये है दैट नेचर हैज डिजाइंड थिंग्स सो ब्यूटिफुली कि आप ऐसा समझ सकते हैं, ये क्वेश्चन नेचुरली आना चाहिए किसी भी स्टूडेंट के दिमाग में, कि जो गैसेस हैं व्हाई डू दे नॉट एस्केप इन द एटमॉस्फेयर, व्हाई डू दे नॉट एस्केप इन इन स्पेस। स्पेस में सारे गैसेस लूज आउट क्यों नहीं कर जाते हम? उसका एक बहुत ही जो ब्यूटीफुल रीजन आपको इजीली समझ में आ जाएगा वो है वो ये है कि एक चेंबर की तरह उस पे एक लिड क्लोज हो जाता है, लेकिन वो लिड फिजिकल किसी सॉलिड मटेरियल का नहीं बना हुआ है, वो गैसेस का ही मटेरियल है, वो गैसेस का ही बना हुआ लिड है। एंड दिस लिड इज द वार्मर एयर दैट रिमेन्स अबव। आप इमेजिन कीजिए, जो साइंस की बेसिक बात हम जानते हैं कि दैट हॉट लिक्विड्स, हॉट फ्लूइड्स, दे राइज अप बिकॉज देयर डेंसिटी डिक्रीजेस एंड द कोल्डर फ्लूइड सिंक्स डाउन। लेकिन अगर ऑलरेडी वार्मर चीज जो है, जो वार्मर फ्लूइड का पार्ट है, जो फ्लूइड का वार्मर पार्ट है, वो अगर ऑलरेडी ऊपर हो तो it is not going to sink down, it is going to remain above, and whatever is at a colder temperature, that is going to naturally, by its property of being heavier or denser, it remains at the bottom। तो यही इसी टाइप का फिनोमेना, इसी तरह की एक इसी प्रॉपर्टी के कारण क्या होता है कि as we go up in the atmosphere, let us suppose that temperature in the troposphere is somewhere around 20 degrees Celsius on average, then progressively as we go up its temperature reduces at the environmental lapse rate of 6.5 degrees Celsius per kilometer। यानी कि for every 1 kilometer that you ascend, temperature decrease will occur at this rate. At every kilometer that you ascend, 6.5 degrees of temperature will come down. That means if this was 1 kilometer, then temperature here would be 13.5 degrees Celsius and so on. अब ट्रोपोपॉज तक ये टेम्परेचर डिक्रीज करता है, उसके बाद ये इंक्रीज करता है, एंड देन अगेन इट डिक्रीजेस एंड अगेन इट इंक्रीजेस. तो टेम्परेचर वर्सेस हाइट का जो ग्राफ है एटमॉस्फेयर का, इट टर्न्स आउट टू बी लाइक दिस. एम को आप ऐसे देख सकते हैं, आप कह सकते हैं कि एम हैज बिन रोटेटेड, ऐसा शेप बन रहा होता है. द रीजन, ऐसा क्यों हो रहा होता है, उसका रीजन है दैट इट इज स्ट्रेटोस्फियर which contains ozone और O3. तो नॉर्मली ऑक्सीजन O2 यानी कि डायटोमिक है इसका स्ट्रक्चर. ऑक्सीजन का मॉलिक्यूल डायटोमिक होता है जनरली, बट बिकॉज ऑफ द हाई एनर्जी अल्ट्रावायलेट रेडिएशंस जिनकी एनर्जी कंटेंट इज हायर देन वायलेट. लास्ट क्लास में हम लोगों ने स्पेक्ट्रम कवर किया था, इलेक्ट्रोमैग्नेटिक स्पेक्ट्रम, विजिबल लाइट का स्पेक्ट्रम, जिसमें कि वायलेट, इंडिगो, ब्लू, ग्रीन, ऑरेंज, येलो, रेड, ये डिक्रीजिंग एनर्जी ऑर्डर में एग्जिस्ट कर रहे होते हैं. तो बिकॉज ऑफ दिस हाई एनर्जी, ऑक्सीजन मॉलिक्यूल्स दे ब्रेक डाउन, a nascent oxygen combines and this leads to the formation of ozone molecule. और आप इमेजिन कीजिए जब कोई रिएक्शन एनर्जी एब्सॉर्ब कर रहा है, दैट मींस इट इज एंडोथर्मिक, तो उसका टेम्परेचर नेचुरली राइज होगा, एंड इट इज दिस रीजन दैट कॉजेज increase of temperature in the stratosphere. Stratosphere, इसका extent 10 to 30 kilometers and up to about 50 kilometers it goes above the equator. Then begins the mesosphere, जहां पे कि आप देख रहे हैं temperature again starts declining. It goes so low as to be minus 90 degree Celsius. जो जिस पॉइंट पे ये एंड हो रहा होता है उसको कहेंगे mesoPause. Again the concept will be similar. जो चीज यहां पे हो रही है वही चीज आपका थर्मोस्फियर में हो रही होगी, और थर्मोस्फियर का ही एक पार्ट होता है जिसे हम कहते हैं आयनोस्फियर. आयनोस्फियर इज क्रूशियल फॉर कम्युनिकेशन टेक्नोलॉजीज, वील सी हाउ एंड व्हाई. तो थर्मोस्फियर में टेम्परेचर अगेन स्टार्ट्स इंक्रीजिंग बिकॉज ऑफ द एक्स-रेज. X-rays come even above ultraviolet rays in terms of frequency. They have higher frequency and that means they have higher energy. Again, this higher energy knocks off electrons. जो electrons होते हैं उसको ये knockout कर देते हैं, X-rays and gamma rays, and thereby there exist ions. Ions are nothing but charged particles जिनमें से कि इलेक्ट्रॉनिक कॉन्फ़िगरेशन उनकी चेंज हो गई. दे हैव लॉस्ट एन एटम और लॉस्ट एन इलेक्ट्रॉन और गेन्ड एन इलेक्ट्रॉन, जिसके कारण वो आयोनिक फॉर्म में, चार्ज फॉर्म में एग्जिस्ट करते हैं. इसका एक्सटेंट यू कैन नोट डाउन इज 80 किलोमीटर्स, एंड एज यू कैन सी इंटेंस एब्जॉर्प्शन ऑफ एनर्जेटिक अल्ट्रावायलेट एंड एक्स-रे रेडिएशन फ्रॉम द सन. रेडियो कम्युनिकेशन में कैसे हेल्प करता है आइए देखते हैं. सो वी नो दैट द अर्थ इज राउंड एंड लेट्स से देयर इज अ रेडियो कम्युनिकेशन टावर. तो अब ये जो सिग्नल्स डायरेक्टली रिले कर पाएगा वो इस पॉइंट के बियॉन्ड नहीं कर पाएगा. एंड इमेजिन सैटेलाइट्स हैव स्टार्टेड in 1960s, 1970s. The technology was not fully developed even up to the 80s and 90s. तो कम्युनिकेशन टेक्नोलॉजी आई मीन, तो अब इस पॉइंट के बियॉन्ड कम्युनिकेट करने के लिए साइंटिस्ट ने क्या तरीका ढूंढा कि वो रेडियो सिग्नल्स को आयनोस्फीयर पे टारगेट करते हैं और वहां पे ये चार्ज्ड आयंस, दिस इज आल्सो रेडिएशन, electromagnetic radiation, electromagnetic waves, and when it hits this, then they reflect it back to earth, and that is how another station anywhere in the world is able to receive. So if it had not existed, if the ionosphere had not existed, communication would have been quite difficult, and this is the critical use of ionosphere for earth. Then region beyond exosphere is when you reach 500 kilometers, and there is no sharply defined boundary, there is no sharp boundary between Earth and space, but gradually it fades into the space, it fades into space. Now we'll look at 4 important days जो मार्क करते हैं ईयर को. इसमें इंपॉर्टेंट बात जानने की यह है कि ईयर का जो मेजरमेंट है ईयर, तो सोलर, lunar, and also with respect to position of fixed stars, इसको बोलते हैं sidereal year. तो इस sidereal year का मतलब हुआ that this earth which rotates around the sun, and an observer from outside the earth, if he or she looks, then all the constellations that come in the celestial sphere, all the 12 constellations, that make, let's say one constellation exists here, one exists here, तो सन के साथ जो डायरेक्ट लाइन में एग्जिस्ट कर रहे हैं, उस तरह से हम डिफरेंट मंथ्स, डिफरेंट सीजन्स को मेजर करते हैं. दिस इज कॉल्ड योर, these are different constellations, imagine them to be different constellations, and this is what is sidereal year, the year that you measure with reference to fixed star groups, that is constellations. Now these 4 important days, इनको समझने से पहले एक और कॉन्सेप्ट जानना जरूरी है, वो है अर्थ की टिल्ट का. तो ये जो अर्थ है, and another important term, axial parallelism. Axial parallelism means that if the earth was in this position, that means its tilt, it is tilted in this way, then it won't go and tilt like this when it is right opposite to its initial position. The axis remains parallel to its prior position, because if this had not been the case, you see, ये जो region है above 66.5 degrees north, this will be in complete darkness because the sun's rays only graze at that point and do not reach it. That is what happens. Arctic and Antarctic experience subsequent continuous daylight and continuous night for 4 to 5 months, not 6 months, but somewhere around 5 months. Then if it had been like this, then again the southern hemisphere, the southern pole would have been receiving continuous daylight for 6 months, and this region would not have received any sunlight. तो आप यहाँ से logically भी इस बात पे को deduce कर सकते हैं that the axis remains parallel. If this had not been the case, seasonality would not have been possible. So the reason for seasonality, other than rotation and revolution, is axial parallelism. Now, what is this winter solstice, summer solstice, vernal equinox, and fluvial equinox? So, when the sun is at this position, it is direct overhead at 23.5 degrees north, 23.5 degrees north, because as it moves, its axis has to remain parallel. So what you will see here, because the northern hemisphere, so if this is southern hemisphere is receiving, then sun will be directly overhead, not at 66.5 degrees north, but 66.5 degrees. Sun will be directly overhead at 23.5 degrees south. And now if this hemisphere is to face 6 months of, this pole is to face 6 months of direct sunlight, then naturally what happens is that now from 23.5 degrees south, sun being directly overhead, यानी कि आपकी shadow 12 o'clock में गायब हो जाएगी, जिसको कहते हैं यही फिनोमेना। तो अगर इस पॉइंट पे सन इज डायरेक्टली ओवरहेड 23.5 degrees south, then at this point of time the sun will be directly overhead 23.5 degrees 23.5 degrees north. So you see the sun is actually moving between Tropic of Cancer and Tropic of Capricorn. Over the year, it moves, its apparent motion is like this because Earth is tilted and keeps moving in this manner. So summer solstice, that means longest day. जो लोग दिल्ली में हैं या फिर अलग अलग शहरों में आपने ऑब्जर्व किया होगा कि समर टाइम में सनराइज अकर्स एट अराउंड 5:15 5:30 डिपेंडिंग ऑन वेयर यू लिव, एंड विंटर्स में वही टाइम शिफ्ट हो जाता है 6:30 तक, यानी कि 1 घंटा आपने इधर देखा कि डे टाइम शॉर्ट हो गया। वही चीज शाम को भी आप ऑब्जर्व करते हैं ड्यूरिंग विंटर्स in Delhi at least around till around 7:15 7:30 there is some twilight, and after that we get darkness. But in winters you see that sunset occurs somewhere around 6:30 in Delhi. तो ये जो टाइम का डिफरेंस है उसी की बात हो रही है यहाँ पे। सोल्स्टिस का मतलब हो गया लॉन्गेस्ट डे। तो ये इंपॉर्टेंट है जानना कि जो नॉर्दर्न हेमिस्फीयर के लिए समर सोल्स्टिस है वही सदर्न हेमिस्फीयर के लिए विंटर सोल्स्टिस, वही सदर्न हेमिस्फीयर के लिए विंटर सोल्स्टिस होगा। दैट मींस इट्स लोएस्ट डे। विंटर सोल्स्टिस मींस विंटर और नाइट विल बी डोमिनेंट, समर सोल्स्टिस मींस summer or daylight, daytime will be dominant. That means daytime will be lengthened wherever there is summer solstice, and daytime will be the shortest wherever there is winter solstice. So you have divided, we have divided it into 4 days. So they will occur at a gap of 3 months each. So if this occurs on 21st of December, because this is the summer solstice for southern hemisphere, for southern hemisphere. But in the northern hemisphere it is winter solstice. And one interesting thing to know from this is that the birth of Christ also, it is a pre-Christian festival, a pre-Christian ritual, जिसमें कि क्राइस्ट के बर्थ डेट को ओवरलैप कर दिया गया, उसके ऊपर सुपर इम्पोज कर दिया गया, बिकॉज पीपल डू नॉट पिक अप एनी फेस्टिवल जस्ट लाइक दैट। अचानक से कोई भी चीज प्रचलन में नहीं आ जाती है, जो चीजें चली आ रही थी उसी के ऊपर आप कोई और नया फेस्टिवल डालेंगे तो इट विल बी इजिली फॉलोड। सो विंटर सॉल्स्टिस, दैट मीन्स द डे, द टाइम ऑफ द ईयर व्हेन there is loss of hope, there is all flowers are not flowering, all plants they are losing leaves, they are shedding trees, तो इस कारण ही there is loss of life seems to not grow, life seems to have decayed. So after that hopelessness, after that time of morosity comes 25th of December, when you see that daylight is gradually increasing, daytime is gradually, the length of the day is gradually increasing. इसीलिए हमने सुना है या छुट्टियों में कैलेंडर में आपने देखा होगा कि बड़े दिन की छुट्टियां कहते हैं, यानी कि नाउ द लेंथ ऑफ द डे स्टार्ट्स इंक्रीजिंग, इसीलिए बड़ा दिन 25 दिसंबर को इंडिया में कॉमनली बड़ा दिन भी रेफर किया जाता है। सो दैट इज द रीजन। नाउ यू मूव 3 months, क्योंकि 12 months का साइकिल और उसको 4 पॉइंट्स में डिवाइड किया है। सो 3 months आफ्टर 21st of December is 21st of March, And this is vernal. Vernal means spring, springtime. So for the northern hemisphere, this becomes spring. That means equal day, length of the day and night will be equal. Equinox, equal night. That is the meaning of the term equinox. Equal night, equal to what? Equal to the length of the day. So 21st or 22nd March, one day. 21st or 22nd December. You understand? 22nd. On this day, neither is it on Tropic of Cancer nor Tropic of Capricorn, sun being directly up overhead. It lies right over the equator. So you can naturally imagine that the lengths will be equal. Length of day and length of night will be equal. Then you again add 3 months and we come to 21st of June. 21st of June, and this becomes summer solstice for the northern hemisphere. For northern hemisphere, but this will be winter solstice for southern hemisphere, and this will be the day when sun is right exactly above 23.5 degrees north. And again we move 3 months. It is 21st of September. 21st of September, and that is known as fluvial equinox for the northern hemisphere, because most of the places are experiencing rains. Fluvial is whatever is related to rivers, rain, basically having to do with water. So these are your 4 days, 4 markers. Again, I'll repeat, this is the day. If it is 21st of December, it is winter solstice. We experience it as winter, but in the southern hemisphere, Australia, South America, these places are experiencing their summers. So it is summer solstice for them and winter solstice for us who dwell in the northern hemisphere. Then we move to 21st March, 3 months ahead, and this is equinox. Equinox means equal day and equal night. Then we move to 21st of June, which is summer solstice for people of northern hemisphere and winter solstice for people living in the southern hemisphere. And finally, we come to another equinox, fluvial equinox, fluvial for northern and vernal for southern hemisphere. Now, one important concept regarding shape of the earth. The shape of the earth is known as oblate. That means somewhat elongated and spheroid, resembling spheroid. You see its equatorial radius. What we mean to say by this is that the shape of the earth is somewhat flattened at poles and bulging at the equator. So that is why the difference is not much, only 20 kilometers. So when you scale it down to the size of any kind of ball, golf ball, cricket ball, tennis ball, so what we realize, what we can understand is that the earth is more spherical or more perfectly spherical than any other sphere. We can easily make this claim. Then this term geoid. So geoid is basically, as said by Gauss, Carl Friedrich Gauss, who discovered or who defined this term geoid. It is basically a mathematical map. You must have seen grid lines. So somewhat on those lines, geoid means a mathematical map of the Earth, and it basically is referring to the variation in gravity due to different distribution of mass. Let's say Himalayas. So Himalayas, there is a lot more mass in that region, so its gravity will be somewhat higher. And because of this, it basically talks about what will be the distribution of oceans and seas in the absence of winds because of variable gravity. That is what we mean by geoid. All you should focus on is that geoid is a gravitational map of the Earth, whereas oblate spheroid talks about its shape, that is flattened at the poles and bulging at the equator. Insolation. By insolation, we mean incoming solar radiation. Incoming solar radiation. Now, we receive 2 billions of sun's total energy, which is very, very less, but still it sustains all life on Earth. अब इसमें 6% जो है, it gets scattered and returned to space by the atmosphere. Returned to space by the atmosphere means whatever light is received by the Earth, scattering means small particles, atoms, molecules, they are hit by light and they return back to space, scattering. Then 21% are scattered and reflected by clouds. The Earth has a permanent cloud cover over some region or the other. You will see through satellite imagery that some region or the other always has cloud cover. So clouds are also good at scattering and reflecting light. So 21% is scattered away like that. Then 18% is absorbed temporarily by the atmosphere, like you saw in processes of ionization or process of ozone formation. So like this, a lot of, or 18% is absorbed, but it is later released as the reaction completes or through other processes, the heat is exchanged and it is given back to space. And finally, 55% of the insolation reaches Earth. The value of this insolation is around 1300 watts per meter square. That means every square meter at the boundary is receiving 1300 watts of energy. Out of the 55% that reaches the Earth's surface, 4 parts or 4% is reflected by surfaces like ice sheets, snow, and light colored sandy soils. So, this is what is known as the albedo effect. The reason why we wear white clothes during peak summers is that it reflects back most of the light, and similarly, because of the same reason, ice sheets, snow cover, they reflect back a lot of light. And this is what we'll know, this is what contributes to global warming and its positive and negative feedback loops. We'll understand this once again. Remaining 51% is absorbed by Earth. It is absorbed by Earth. Now, what is this Goldilocks zone? So you see, in the last class, when we were talking about the solar system, so we saw there are 9 planets: Mercury, Venus, Earth, Mars, asteroid belt, Jupiter, Saturn, Uranus, and Neptune. So if you remember, we called these 2 planets ice giants. And we know that Mercury and Venus are very, very hot. Temperatures over there reach almost 250 degrees Celsius. And here they reach minus 250 degrees Celsius. So here it is impossible for water to remain liquid. And here too, this thing will apply, because here it is always frozen. Everything is frozen. But Goldilocks zone is that sweet spot, that region Goldilocks zone is that region of space where water can exist in liquid form. And why are we so worried about water existing in liquid form? Because life originated in water. That is why, if we want to find out where on other planets, on other stars, life can exist, then one of the things scientists look for is this Goldilocks zone. They prefer to look at planets that exist in this zone of temperature, because here, one of the only planets that we know of till now, Earth is the only planet where life exists, and we try to find out similar conditions. What conditions were there that led to the development of life on Earth? So, this is one of the important things which comes out. It is named after the story of Goldilocks and the three bears, Goldilocks and the three bears, in which the number three is used multiple times, three bowls, three cups, and things like that. How it comes is that, see, in the first attempt, let's say there's a robot, artificially intelligent robot, and you ask it to pour some water in a cup, in a jar. So what it does, that it pours too much and it overflows. The first round, the first attempt. In the second attempt, you again see that it pours only 2-3 drops and again stops. It pours very little, very much, very little. And in the third time, now it has learned that should not go beyond this point and should definitely go beyond this point. So in the third time, it fills it just right. Just right. That means Goldilocks zone is that zone of space where the temperature is just right for life to exist. Albedo effect, reflectivity, ability of a material to reflect sunlight. Now, positive and negative feedback loops, what they mean is, imagine that lot of ice cover is there. So now it ends up reflecting all of the rays back to space. Whatever light it receives, whatever heat it receives, it ends up reflecting it back to space. So now this cools down the temperature, and cooler temperatures will lead to furthermore formation of ice. Again, more ice will reflect back more of sun's energy, and more ice will be formed. So this is a positive cycle in which the effect leads to its own, the cause leads to its increase. The cause is the ice, and this ice is leading to more ice. So that is positive feedback loop. And where the effect causes the cause to reduce, that will be a negative feedback loop. These are important for understanding climate change. Then geological cycles and ice age. So such kind of phenomena over long periods cause ice ages. Geological timescales are measured in terms of millions and billions of years. Therefore, we know that there have been multiple ice ages. Multiple ice ages. Ice age, that means that time period during which Earth is surrounded by ice. Earth's surface is covered by ice. And we actually are living in an interglacial period. We are living in an age that is between two ice ages. Now, why do these ice ages occur? So, one of the theory is that of Milankovitch cycles, or we call it astronomical forcing. Astronomical forcing, that is forces outside from space that cause change in temperature. So one important thing that you should know is that the axial tilt, the tilt of Earth, is not constant. It varies between 22.1 degrees to 24.5 degrees. Right now it is 23.44 degrees to be precise. The current tilt is 23.44 degrees. Now this tilt itself, what you must know is you can call it either 23.44 degrees, but this 24.33 degrees is with respect to the perpendicular you draw. This is 23.44 degrees. But if you see, with reference to this, it is nothing but 66.5 degrees. So, if this is the orbit of Earth, then its inclination with reference to the plane of ecliptic. This plane is called the plane of ecliptic, and with the plane of ecliptic, the tilt is 66.5 degrees because it is a complementary angle of 23.5 degrees. Now, what you must know is that this axial tilt itself is not constant over a time period of 41,000 years. It goes from 23.5 to from 22.1 to 24.5. And now you can appreciate the fact look, if it is tilted more, that means more of ice cover will be receiving sunlight and more sunlight will be reflected back, which will lead to that positive feedback loop, which will cause further formation of ice. So that is why these things become important. Eccentricity of, so a circle has zero eccentricity, but we know that the orbit of Earth, the shape of Earth's orbit, if this is the sun, then it is somewhat elliptical. Value of its eccentricity is roughly 0.6. So this eccentricity, now understand that if it is circular, it's a different matter. Everywhere the heat distribution will be same at all positions. But if it is elliptical, then at some point its distance will be lesser and at some point its distance will be more. That is why we have these two terms called perihelion we have aphelion and perihelion. Helion meaning sun. So the distance of the sun when it is maximum and when it is minimum. So there are two different distances because of the eccentricity, and this eccentricity keeps changing. It varies between becoming a circle and becoming an ellipse. It never becomes a complete circle, but it goes towards being an ellipse with higher eccentricity and ellipse with very less eccentricity. Then there is another phenomena not written down here that is called Apsidal precession. That means orbit of the earth itself keeps moving. Apsidal precession. Precession motion, जब कोई लट्टू घूम रहा होता है, एक लट्टू का मोशन आपने देखा होगा, तो other than moving on its axis, it is also wobbling. That wobbling motion, that tracing of body cones is called precession. And this is a precession of the whole orbit. But then axial precession also occurs. That means if this is the earth and this is its axis and it points towards, currently it points towards pole star Polaris, but this itself will precess the earth itself. While moving on its own axis, it will precess slowly and make these motions. And this time period is 25,000 years. So at some point in the future, another star will be our pole star, which will not be Polaris. So these are the causes of long-term geological scale climate change, and that is why we have some climate change deniers who deny that it is not human actions that are causing climate change, it is the result of these natural phenomena. You must know the name of this scientist, Milutin Milankovitch, if you want to note it down. A Serbian by birth who discovered these cycles. Greenhouse effect. We all have heard what is greenhouse effect. People generally relate it directly with carbon dioxide. But what we need to know is that greenhouses are actually glass houses made to conserve heat. Now imagine you are in a remote hilly region somewhere in Himachal, Uttarakhand, where sunlight remains for a very short period of time, and you want to make a herbarium, you want to grow some vegetables, but the temperature becomes very, very cold at night. So what are you supposed to do? You build a glass house, and now we did cover the electromagnetic radiation concept in last class, but I will repeat it again. So when the sun is radiating energy, it is high intensity. High intensity, that means we call it short wave. Wavelength is short. So short wave. Wavelength is short and frequency is high. So these are able to penetrate this glass house easily. But when the sunlight is over, daytime is over, and this has been sufficiently heated, so now it will start radiating back. But since it is long wave radiations, that means, see, the thing is, any body that has any amount of heat, that will radiate infrared radiations as heat as infrared radiation, but it does not have enough power to cross the boundary of this glass house, and that is why heat is trapped. Heat is trapped. So this trapping of the heat because of change in or difference between sun's waves, sunlight, and the heat of the body, that effect is known as greenhouse effect. That effect is known as greenhouse effect. So the concept is simply this: light is nu lambda. Lambda is its wavelength, nu frequency, or how frequently in 1 second, how many times that cycle of vibration occurs. And so, if one factor goes up, the other must come down in order to maintain the constant speed of light. So, short wave radiations or radiations whose wavelength is short, frequency is high, and then therefore their energy is high. Another important thing that we need to know, that you must have realized, is that, or if you have not realized, here goes: the earth, the atmosphere of earth is not heated directly by the sun's incoming radiation. It is heated from below. When the earth is sufficiently heated and it's nighttime, the earth starts heating, or even before nighttime, when the earth has heated up, that is when it starts heating the atmosphere. That is when it starts heating the air above its surface. And that is how climate works. So, in case of earth, what this greenhouse effect does: greenhouse effect when certain molecules, sulfur hexafluoride, and you will be surprised to know that even water, existing as water vapor, even that is a greenhouse gas, because it is able to absorb heat and maintain that heat. But why CO2 becomes a problem and H2O does not is because H2O molecule remains in the atmosphere, remains in the atmosphere for a very short time, for a very short period of time. Whereas this, it has an average life of 100 years before it breaks down. Average life of 100 years. Once a CO2 molecule is formed, it will stay on an average in the atmosphere for an average of 100 years. So repeated absorption of heat, release of that heat will keep taking place. And it absorbs, if you are asked a question that does it absorb sun's direct energy? No, it absorbs long wave radiations. It absorbs long wave radiations, and that is how it heats the atmosphere. So these greenhouse gases, it is not like they are a nuisance. Actually, they act like a blanket in the space, in the cold space. We would have been very cold if the earth had radiated back all of the heat. लेकिन ये एक तरह के कंबल का, they act like blankets, these gases, by trapping that heat. So they are very, very important. The problem is that CO2 used to be only 280 parts per million during the industrial era, during 1700s, 1800s. But from that time around to present, it has become 420 parts per million. Parts per million, when we want to measure things in very small, that exist in very small quantities, we use this measure of parts per million. If I randomly capture 1 meter square of area and capture all the gases, then I will find that 420 particles belong to carbon dioxide. That is what its meaning is. Now let's move to the process of cloud formation. Dew point. What do you understand by dew point? Dew point is that point of temperature. That temperature, because temperature is measured on thermometer, so that point on the thermometer at which water begins to condense, water vapor present in the atmosphere begins to condense. Let us say that there is 80% humidity. 80% humidity. at, let's say, 40 degrees Celsius, and suddenly, for some reason or the other, the temperature drops. Or a better example would be seeing a glass of cold drink, any kind of cold drink. So, when we pour any cold liquid in a glass, we see that lot of water droplets form on its surface, on the surface of the glass. The reason is that there was already moisture present in the air, water vapor. And as it loses its heat, water vapor is in that state because it got some heat, it absorbed some heat. Now, when it is able to find a surface where it can lose that heat, it deposits that heat here, or that heat is exchanged, because heat always goes from hot body to cold body. So these droplets start forming. Now, before we go any further, I would like to tell you a little bit about the concept of difference between boiling and evaporation. So boiling is a bulk phenomenon. Whereas evaporation is a surface phenomenon. इसका मतलब ये है, जब बॉयल करते हैं चीजों को आप, तो आप देखते हैं कि उसमें से कुछ एयर बबल्स भी आ रहे हैं नीचे से, जबकि इवेपोरेशन, you don't need to add any heat from outside. Evaporation is a spontaneous phenomena, it occurs on its own. इसीलिए वाटर का ट्रिपल पॉइंट भी एग्जिस्ट कर रहा होता है. ट्रिपल पॉइंट मतलब कि वो टेम्परेचर जिसपे पानी तीनों ही स्टेट में एग्जिस्ट कर रहा हो, सॉलिड, लिक्विड एंड गैस. हाउ दिस ट्रिपल पॉइंट इज 0 डिग्री सेल्सियस. अब ये क्यों एग्जिस्ट कर रहा होता है तीनों स्टेट में? जब आप फ्रिज से आइस निकालते हैं तो आप देखते हैं कि उसमें कुछ वेपर्स ऑलरेडी निकल रहे हैं. तो सरफेस फिनोमेना, योर क्लोथ्स दैट द क्लोथ्स दैट ड्राई, it occurs because of evaporation. And this evaporation being a surface phenomena, it only means the fact ki now we know that all matter is composed of tiny particles, and these particles keep bumping against each other. So this tries to, it gains energy and it tries to leave, but there are particles of air as well, they again collide and come down. And this keeps happening, be it ice at 0 degrees Celsius. 0 degrees Celsius does not mean ice does not contain any heat. It has a lot of heat compared to an object that is at minus 70 degrees Celsius, compared to water that is at minus 70, or ice that is at minus 50, minus 60, minus 70 degrees Celsius. In Siberian region, temperatures go down even to that extent. So it definitely has a lot of heat, and therefore on its surface as well, lot of particles will keep evaporating. Water starts freezing at 0 degrees Celsius, and water starts melting as well at 0 degrees Celsius. So 0 degrees Celsius is the triple point of water. What you must be getting confused with now is because of what is known as latent heat. So latent heat is, latent means hidden. Why hidden? Hidden from what? So you must have heard in your school, or you must have solved this question, that what will cause a more severe burn? Water at 100 degrees Celsius or steam at 100 degrees Celsius? So the answer is steam at 100 degrees Celsius, because when we boil, the definition of boiling point is that temperature. That means now addition of extra heat will not change the temperature. That temperature at which water starts converting into its liquid water, or boiling point, is when any liquid, that temperature at which any liquid starts converting to gas without changing its temperature. That means addition of further heat when any substance, when any liquid has reached its boiling point, addition of further heat will not reflect in its temperature. Temperature won't increase. Where is that heat going? That heat is going to change the state, to change the phase of that substance. In case of water, at 100 degrees Celsius, even pressure is involved at given atmospheric pressure. This definition involves at given atmospheric pressure. That means if you are boiling water at 100 degrees Celsius at the sea level, it will boil at maybe a little lesser, 95 degrees, 90 degrees Celsius if you are on a hill. And as high as you go, there is less pressure, there is less compression by the atmospheric pressure, and therefore you are able to let the water boil at lesser temperature, at lesser amount of heat. It does not have to resist more pressure. As you go up in the air, in flights, you must have experienced your ears popping. The reason is pressure decreases, and we humans were manufactured at the sea level, born at the sea level. That's why our pressures are according to the sea level. चिप्स के पैकेट आपने देखे होंगे कई बार की hills पे जाकर के hilly regions में, they are almost, it seems as if they are about to burst. The reason is they were manufactured at the sea level, and now when they go up, the pressure within is able to resist the pressure outside, and therefore the packets inflate. So latent heat is the hidden part of heat, the heat that does not reflect in temperature but helps convert the state of matter. That is latent heat. And now you will understand these terms. So we already know environmental lapse rate, 6.5 degrees Celsius per kilometer. Boiling point and latent heat, I hope you have understood. Then dry adiabatic lapse rate. This word adiabatic means, it comes from A, means not or absence, the prefix A. Dia involving two. What two? One side to another side. Two sides are involved. That means diaphanous material, through which light can cross and you can see through that material. Dia, across. And batikos means heat. So adiabatic means no heat is able to be, or no heat is exchanged. No heat is exchanged. The processes in which temperature changes without direct heat being transferred from one body to another, such processes are called adiabatic processes. A simple thing that you can do is, in your syringe, you won't be able to observe in any kind of syringe, but the experiment goes that if you have gas in a chamber and there is a piston above, so if you very slowly compress the gas in a smaller volume, its temperature is going to increase. You did not add any heat. You did not add any heat to this gas chamber. Still, you were able to increase its temperature because you are compressing it to a smaller volume. Without adding heat, temperature is changing. Or a very good example that you can understand through are perfumes. The moment you spray perfume on your body, you feel very, very cold. The reason is that perfume that was compressed, gas that was compressed to be liquid, when it comes out of the pressurized can, it expands. And because of this expansion, it cools down, and that is why you feel cold. So something similar goes on in cloud formation, in cases of cloud formation. Environmental lapse rate, 6.5 degree Celsius per kilometer. Dry adiabatic lapse rate, that means dry as against saturated. So meaning of saturated is when you cannot add any further solute to the solvent, that means it is a saturated solution. When you can't dissolve any more sugar in water, it is saturated. So what do? How are sweets made? How is syrup made? You heat that water. When you heat water, the particles, water has thermal expansion. It goes through thermal expansion, and you are able to add more salt or sugar, whatever you are making. So in case of syrup, in case of sweets, when sweets are being made, so water is heated, syrup is heated, it is boiled. multiple times, and therefore it is able to accommodate more sugar in it. So when humidity reaches 80%, 90% at a given temperature, what happens? Let's say a, a small parcel of air containing some moisture, because it has been intensely heated, it begins to rise up. It starts its journey upwards. It begins its journey upwards, and as it is going up, you must realize now that the pressure exerted by the environment as it goes up, it goes on decreasing. So this parcel of air is able to expand, and as we just saw, when it expands, its temperature is going to come down. But now begins the real game of water, or water condensation, we can say, or cloud formation. Now understand that the only reason why this parcel of air is going up is because it was hot. It was hotter than its surrounding, and hot things, they are less dense, so they will rise. But as it goes up and it cools down, it reaches its dew point because it had much more moisture that can be contained at a lower temperature. So it will begin to cool down and therefore not rise up. Now it has this problem of it will come to a certain height and it will stop rising up if it has no more heat. It was the heat that was propelling it up. So now comes latent heat in play. Latent heat comes into play. As the temperature decreases at this rate and pressure decreases, that parcel of air is cooling down, therefore liquid begins to form. It will rise further up. Only when it goes further up, clouds will be formed, because a lot more moisture needs to be condensed. So that happens because as water condenses, as water cools down, it will release that heat because it has now converted into its liquid form, and it converted into its gaseous form only after absorbing some heat. And you remember, this was latent heat. That means it does not change the temperature. So now, without any addition of heat from outside or releasing any heat to outside of that air parcel, if more heat is released, so this air parcel is further more heated, it goes further up, and therefore bigger clouds are formed. So this is also a heat engine. Cloud formation itself is a heat engine process. So this is it. We will stop here for today. And if you have any doubts regarding this cloud formation process, just go through the concept of boiling, evaporation, and latent heat. If you understand what is latent heat, then this concept becomes very easy for you to understand. I will repeat it again. The air parcel begins to rise. It is moist. It has a lot of moisture. As it ascends in the atmosphere, it begins to expand and therefore cool down. And this expansion will lead to cooling, and this cooling will lead to water droplet formation. And water droplets are coming not from anywhere else but by condensation of water vapor, and this condensation will release more energy, which will further heat the air parcel, and it will rise further up, and it will form a cloud, which is a lot of water droplets coming together. Thank you.